Kia ora and welcome to video 11 in the series Delightful Differentiation. This problem here involves the use of the chain rule. We've got some functions f and g that are composed to make a and b, and the question asks us for what values of x are the functions a and b decreasing, and we're just focusing on the interval 0 to 2 pi. So good luck with this question, and after the intro music we'll see you for the solution. Okay, for this problem we need the chain rule. Function a and b are composite functions. So a is f of g of x, meaning we need to work out the value of g of x and then substitute into the f function, and vice versa for b. We're on the domain of 0 to 2 pi, and we're looking at values of x in which the functions are decreasing. The graph gives us the functions sine and cosine of x, because that's going to be useful for us. But first up, decreasing means that the gradient is less than 0. So we go about finding the gradient functions for a and b of x. A of x, what's that function? F of g, or f is sine and g is cosine. So sine is the outer function and the cosine is the inner function. And the opposite for b of x, cosine being the outer function, sine being the inner function. And we differentiate these. So a dash of x, chain rule applies here. Differentiate the outer functions, cosine of x, but the inner function stays the same, and then times by the derivative of the inner function, which is minus sine. Likewise for b dash of x, the outer function is cosine, diff that to minus sine, inner function stays the same, and then multiply by the inner function differentiated. And we need to consider what values of x on the domain of 0 to 2 pi these things are decreasing. Gradient less than 0. Okay, I think it's easy to set up some sort of little table here and split the x values across the four quadrants. So if I make a table, probably have used a ruler, but never mind. Case. Okay, so the case 1 is the first quadrant, Q1. So x between 0 and pi over 2, and then we've got Q2, Q3, and Q4. And then if we consider first up the values of sine and cosine. So sine of x on 0 to pi over 2 is positive. Quadrant 2, it's also positive, and then it's negative for the other two quadrants. You can look at the graph there. Sine x is in red. First two quadrants, here and here. Bearing in mind though that on those quadrants, the first quadrant it's increasing, the second quadrant's decreasing, and that's important as well to take note of. Cosine of x, the first quadrant's positive and decreasing. The second quadrant is negative and still decreasing, and then it flips around to increasing, and then positive eventually in the fourth quadrant. Okay, so cosine of x is positive, then negative for the second and third quadrant, and then positive for the last quadrant. And then lastly, we need to consider a dash and b dash. So a dash, this function is cosine of cosine times minus sine. Okay, so what's happening with this one? The outer functions help, like we already know about that, the minus sine of x. We can look at this part here and go, okay, well sine of x is positive, and there's a minus in the front, so it's negative. But we need to consider the other factor and whether that's positive or negative. So the inner function, cosine of x, that is positive, and it ranges between 0 and 1. So cosine, if it ranges between 0 and 1, and then we're taking the cosine of that value. So if the inner part is between 0 and 1, and then we're taking the cosine of that, we're still going to return a positive value. So the whole thing here is positive, but then we're timesing by a negative, so that's less than 0. Quadrant 2, again the thing at the end is positive, the sine of x term, but there's a minus in the front of it. This is where we need to consider the inner function being cosine. Cosine is negative, and it will be between 0 and -1. And then the cosine of that is, let's have a look. So if we're first up, we're in the second quadrant for this case, so we're going to get cosine is going to be somewhere between -1 and 0. And then we're taking the cosine of that result again, which means that we're over this side between -1 and 0, and we're going to return a positive value. So the first time we take the cosine, we're in the second quadrant, we take the cosine of it, and it returns a value that is between -1 and 0, which puts us in equivalent to the fourth quadrant, which means it's a positive value. So the cosine of the cosine is positive. We're timesing by negative the sine. Sine's also positive, so we're getting a negative value there. Third quadrant, sine of x is now negative. We've got a double negative at the end of that, minus sine of x, so it's positive. The internal part, cosine of x, is negative, and it's going to return a value of 0 to -1 again. And then the cosine of that is going to return a positive. So we end up with positive overall. And then lastly, this one here, cosine is positive in the fourth quadrant. So the inner part of the function, cosine of x, is going to return a positive number between 0 and 1. And then we take the cosine of it again and we get a positive. So we've got positive times negative sine. Sine's negative, so it's positive. Okay, so we end up with minus between quadrant 1 and quadrant 2. And we just need to do the same thing for b of x. So I'll spare you the details. If we look at b dash of x, and you can confirm this, we end up getting minus sine of x times cos. And in summary, you should find that b is decreasing in the first quadrant and in the third quadrant. So you should get negative here and negative there, and positive there and positive there, using the same logic as what I just did for a dash of x. Okay, so in summary, a of x is decreasing on 0 to x to pi, so the first and second quadrants, and b of x is decreasing between 0 and pi over 2 and between pi and 3 pi over 2. Okay, let's just have a look at a graph just to confirm that we've got the right answer here. So let's bring up Desmos. Okay, so we can see the purple one there is g of f of x, that's what we did second. Green one, f of g of x. So the green one is decreasing all the way to pi. So in other words, the first and second quadrants, and then it increases up to 2 pi. And the purple one decreases up to pi over 2, the first quadrant, then increases again, and then in the third quadrant, from pi to 3 pi over 2, it decreases and then increases again. Based on how these functions kind of look, I imagine that you could probably do it in a different way to what I've done. Maybe in the comment section below you can summarize your method if you did something a bit differently.